Okay, everybody. In this video, I'm going to explain this linked structure. It's not very easy to understand, so I'm going to explain it. Okay, a linked structure is that you can use one object to point to another one, and then point to another one, so that from one object, you can get to the next one. An example is this part. Okay, this means we call this self-referencing. That means you have this class person, right? It can contain a reference to another person. So a person has a person. That is called self-referencing. So for this one, you have the basic attributes for name and age for a person. That's the essential attributes you must have that describe a person. And then you add this attribute. You add a reference variable, and it's a person type so that it can point to another person. That is what self-referencing is. Okay, how does that work? That is like this. I drew it here, painstakingly drew this. So what does this mean? Suppose these are all person object. Okay, this is a person object, person object, etc. So we have 5 of them. And the first person's object is the first person's address. This object's address is 1000, suppose, okay? And this is a stack because you understand stack. So this is the top one, the one after the top, and this is the bottom one, okay? The bottom one is not linking to anyone. So its person object's address is null, okay? The top one, this is the top one. Suppose it's a person object. It contains a person reference variable. And that, what is a reference variable? First of all, a reference variable is simply a reference. That means it contains an address, not an actual value, right? It contains an address. So this person's reference variable contains an address that's for the next person, which is, I just give it random numbers, 1200, and that's the next person's address, 1200. And this person object contains the address for the next person object, which is 1400, okay, and so on. And so the last person object, that's the first one to be pushed, right? It's the bottom one. It doesn't point to anyone because it's the first one, it's the bottom one. There is no next. And so it is null. It doesn't have an address to point to. So that is null. Okay. And so if this is a stack and this is the front, right? And so this is the reference variable front. It points to this node. And so its address is 1000. I'm putting, so the top row are the addresses for each object, okay? And then these are the addresses for the next person object. So that's how this works. That's what this means, okay? Now let's go to the next slide. I want to talk about this. So this is, what do we do? This is, we want to add an object to it. Okay, so let's discuss this. Suppose you want to push an object, and here is the person object you want to push. It has a name, it has an age, and it also has the next reference variable. But we do not know which one is its next. So currently it's actually null, right? It's not pointing to anything. So you want this, you want to push this, that means this would be the top. But so this would be the top. Suppose this address, let me just put this here. Oh, I can just do this. Okay. Suppose this address is how much? 2000. Let's make it 2000. Okay, that's where this object is. We just created, and it's at 2000, and it doesn't have a next because it doesn't know who to point to. And so if you want to push this object, this person object to the top, can you simply do this? I will say now my front is this one. And you will just change your front address instead of 1000, which is this one. Now you can just change it to 2000. Can we do that? So if we do that, okay, this is the front. That's what this is saying. Okay, this is what this is saying. If you say this is the front, then this node is front, but its next is null, which means you are not linking to this stack. You lost the whole chain. So this whole thing is gone. You only have one node right now. All these are gone. So that's not the right way to do it. And that's what this means. You cannot assign front to the new node first. Okay, you cannot say front is equal to 2000. The address is 2000. You cannot do that. So how do we do that then? How do we push this there? To push that there, we can, okay, let me change this back to 1000, right? Okay, to push this there, first, we need to make this node connect to the whole stack. And that's what this means. We need to make this node connect to this stack. That's the first step. Okay, make it connect to this one. So how do we do that? We simply make the person reference variable to be this node. And this node's address is what? 1000. So now we just say 1000. Okay, that is this step right here, this step. Okay, and then now this one, even though it's here, it doesn't matter where it is, it has a reference pointing to this node, right? So now we can say front. I will change the front address now. Front now is not pointing to 1000, it's pointing to 2000. So basically, visually, what you are doing is you are putting this here, and its address is 2000, and now your front is pointing to this node. So this becomes the front node. Okay, that is what this is doing. So new node.next is equal to front. You have to set this first, and then you do front is equal to new node. Then you change this address. That's how you push. When you pop, okay, so the front now is 2000, right? Not 1000. The front is 2000. You place it into a variable, into a reference variable, okay? So, oops, not very good. Okay, so let's put it here. This is a person object, and you put that address there. That address is what? Right? You put it there so that you can go and get it. So we remember it now. And then now, since we have it somewhere, we won't have to worry that it will be lost. Okay, so that's our object. We put it there. And now what can we do? We will just take it off, and then we can make this front node to point to this one. And what's the address of this one? It's 1000. So your front new address should be 1000, but you don't know really. You do not know. How do you get that 1000? You get that 1000 from this front node, the current front node. It has the address for the next node, which is 1000. So your front address, once you put this into an object reference variable, so you can reference it, okay, that's the one you popped. And now you can change your front address to this current front's next element. Okay, and that's what this is. Let's go to the next one. So you first get the content, right? Put it into, get the address of the actual object, put it into the same object type, and then you change your pointer. Your front now will point to whatever is contained in the current front's next. So the current front's next is 1000. So your new front is 1000. Okay, I will change it here. I wrote this before. Okay, so we use front is equal to front.next to get to this one. And now this one, you really, it can still be here, but no one is referencing it. Your stack is not referencing it. Your stack is referencing, your stack is referencing this object. So this is really just there, and you already remembered it, and you get the content, you use it, and that's it, right? That's how you pop, and that's what this is. Okay, so you have to make sure you reconnect it. That is what that self-referencing means. But if you think about it, okay, so I have a person class. Okay, I have a person class. I have to add something to it. I have to add a reference variable there, self-referencing. If I have a book class, I need to go to the book class to change it. I discussed that here, I think somewhere. Okay, so here, okay, I discussed that there. It's not practical. I will let you read that. It's not practical to modify each class you want to place in the linked structure. You cannot go into that class to modify it because that really violates the encapsulation rule, right? Information hiding. You are given a class object, you should not know what is inside. So you should not be able to modify it. So this self-referential way really doesn't work. This one, it doesn't work. It's not practical, and it violates information encapsulation. So what do? We think of a way to do this, which is this. Okay, so what this means is we make a package, we make a new object, and let's say we name it LinearNode. Okay, you can name it anything, but LinearNode is more reasonable. So you make this new object, and your new object should have two fields, two attributes. One attribute is of a generic typed object so that you can put any object in it. Another reference variable should be the same as this LinearNode so that you contain the address that points to it. That's what this is, okay? So I'm going to use this hopefully to vividly depict that. So let's see, this is a LinearNode, okay? It's, as I said, it's like a package. So in it, you have really two fields, okay? Two. So the first one is the address for the T element. Okay, so you have a T element. And remember, this T element is a reference variable. So it's basically an address. And the second field or attribute is the address for the next linear node. Okay, so instead of having a linked structure of person or a linked structure of book or any other objects, we have a linked structure of linear nodes. And this linear node has two fields. So this will be the address for the next one. I didn't put the address there, but okay. I should have put the address there, but that takes a little bit time. So this address is, I can just copy that. Okay. So this one would be 16. And this one, okay. And this one we do not need. Okay, so this is 12,000. 1200, and this would be 14. Okay, that's the address for this linear node itself, okay? So what does this do? This is the front linear node. It has two addresses, so this would be 1000 then, right? Let's say it's 1000. Okay, so its own address is 1000, and it has two parts. One is the actual element you want to place on the stack. It's generic, and its address is right here. That's the actual book object. Suppose you want to have a stack of books. Okay, so this is one reference variable of type T. And this is a reference variable of type linear node so that it can point to the next one. And it contains the address for the next one. So, and this one contains the address for the next one. And this one contains the address for the next one, okay? And so this is how a linear node works. And for this one, it's pointing to an element at position 400, not position address for 4000. And this one has an element at address 5000, that's this one. And this one at address 6000. So these can be anywhere. They don't have to be in order. These usually are in order, right? But these don't have to be in order because they are on the heap and it can grow and shrink. It doesn't matter. So that's how this linear node works. It has two attributes. Both of them are reference variables. The first one, that's the basic one, that's the substance. That is the element itself, okay? But because it's a reference variable, it still contains only an address. You go to that address, you get the actual book object. And another part is an address for the next element. So this way they are connected, okay? They are connected. And if you look at this, this is what it means. This part is this, what do you call that? Okay, I'm going to do this. Okay, so if you look at this, this is pointing to it, right? Okay, I need to do this. Okay, so this is pointing to it, but that pointing simply means it has an address that points to it. That's what I was trying to show you here, right? That's actually something like this. When you implement it, it's actually an address for the next one. Okay, and this is pointing here. That's the actual T element, and that's actually the address for that element. And you can see it's somewhere. It's not within it, right? It contains an address for that element. So this is the address for the next one. It has the address for the next one, and then it has the address for this actual element. So that's how the linked list works, how this linked structure works. I'm going to stop here. I will do a video for the linear node, a class, to implement that, okay?